Proxima b. So, what's the story? Is it Earth-like? Yes, but that's not the most interesting part. We have discovered plenty of Earth-like planets, but what's significant is that Proxima b might be the closest planet to us beyond our solar system. If it has an atmosphere, the greenhouse effect could raise its temperature above 0 degrees, placing it in the liquid water habitable zone. In the vast expanse of the cosmos, a beacon of light pierces the darkness, revealing secrets long held by the universe. The James Webb Space Telescope, humanity's most ambitious eye on the sky. It ventures beyond the known, pushing the boundaries of our understanding as it gazes upon Proxima Centauri, a mere 4 light-years away. It uncovers whispers of a world unlike any other, Proxima b. Amidst the cosmic silence, an anomaly sparks a cascade of questions. Artificial lights flicker from the surface of this alien world. Could this be the evidence we've been searching for? Are we on the cusp of uncovering a civilization beyond our own? The James Webb Space Telescope is upsetting the apple cart. Suddenly, we realize that we may have to rewrite textbooks about the beginning of the universe. For as long as humanity has gazed at the night sky, we have been captivated by the tantalizing mystery of what lies beyond our world. This ancient curiosity, woven into our collective imagination, drives us to ponder the existence of life among the stars. At the heart of this cosmic quest stands the James Webb Space Telescope, a marvel of human ingenuity and the most powerful telescope ever constructed. Launched with the promise of expanding our understanding of the universe, JWST serves as a bridge between the dreams of our ancestors and the possibilities of our future. With its unprecedented capabilities, it peers deep into space, unraveling mysteries that have eluded us for generations. As it trains its gaze on Proxima Centauri, our nearest stellar neighbor, and its intriguing planet, Proxima b, we stand on the precipice of potentially groundbreaking discoveries. Could this advanced observatory, floating 1,000,000 miles from Earth, finally provide answers to one of humanity's oldest questions? Are we alone in the universe? Observations of Proxima Centauri reveal a celestial anomaly emerging from the depths of space, capturing the collective imagination of Earth's greatest minds. Proxima b, bathed in mystery, lies within the closest star system to our own. Through the eyes of the James Webb Space Telescope, scientists have observed peculiarities that defy conventional understanding. These are not mere flickers of cosmic radiation or reflective natural phenomena, but what appear to be artificial lights shining defiantly against the void. This extraordinary discovery propels us into a realm of speculation and wonder, challenging preconceptions of life beyond our solar sphere. Are we witnessing the first concrete evidence of an alien civilization? Could Proxima b be home to intelligent beings gazing back at us across the cosmic expanse? The search for extraterrestrial intelligence, SETI, began in 1984, born from the bold curiosity of astronomers Jill Tarter and Thomas Pearson. They launched an ambitious endeavor to capture the faint whispers of the cosmos through spaceborne radio signals. Their goal: to find evidence of civilizations beyond our own. Armed with an array of 42 radio telescopes nestled in California's Cascade Mountains, they listen to the universe's frequencies, hoping to detect a pattern or signal that suggests we are not alone. Yet, despite advanced technology and decades of dedication, no verifiable alien signal has been detected in over 30 years. The launch of the James Webb Space Telescope marks a monumental leap in our quest to understand the cosmos. Equipped with highly sensitive detectors, it embarks on a mission to explore distant planets, casting its gaze into the vast cosmic distances where the universe's secrets lie hidden. This endeavor not only showcases our technological prowess, but also heralds a new era of astronomical discovery. Since the discovery of the first exoplanet 2 decades ago, astronomers have unveiled over 4,000 distant worlds orbiting stars far beyond our solar system. This remarkable feat suggests our galaxy, and indeed the universe, may teem with trillions of exoplanets, each with its own story, potentially rewriting what we know about the possibilities of life beyond Earth. JWST's mission is not just a journey through space, but also a voyage across the frontiers of human knowledge, promising insights into the age-old question of whether we are alone in the universe. The James Webb Space Telescope represents a quantum leap in the search for life beyond Earth. Equipped with precision tools to detect the faint signals of distant worlds, JWST searches for the vegetation red edge, a biosignature signal from terrestrial plants that mixes red and infrared light, a beacon of life as we know it. Additionally, JWST employs spectroscopy to decipher a planet's atmosphere by analyzing its light spectrum. As sunlight passes through an exoplanet's atmosphere, certain wavelengths are absorbed, leaving a spectral fingerprint. These fingerprints reveal the presence of elements such as oxygen, nitrogen, and carbon dioxide, crucial for life as we understand it. Yet discerning between geological and biological processes that produce similar atmospheric signatures remains a complex challenge. Proxima b lies a mere 4.25 light-years from Earth, orbiting the red dwarf star Proxima Centauri. It captivates astronomers with its potential for harboring life. Discovered in the Goldilocks zone, where conditions may allow for liquid water, Proxima b presents both possibilities and challenges. Its proximity to its star subjects it to intense solar winds and radiation, casting doubt on its ability to retain a life-sustaining atmosphere. However, its orbit also bathes it in enough sunlight to mimic Earth-like conditions, if an atmosphere exists. Proxima b's tidally locked nature means one side of the planet is always in daylight, while the other is in perpetual night. This raises questions about its climate dynamics and the stability of liquid water. Furthermore, Proxima Centauri's strong solar flares could threaten atmospheric stability unless Proxima b has a protective magnetic field akin to Earth's. The James Webb Space Telescope embarks on a quest to uncover the technological signatures of life, focusing on the presence of chlorofluorocarbons, CFCs, in exoplanet atmospheres. These chemicals, byproducts of industrial activities on Earth, may signal the existence of technological civilizations. Yet the universe weaves a tapestry of complex processes that mimic the fingerprints of life. JWST faces the challenge of distinguishing between natural and artificial signals, sifting through the cosmic signatures of life. Exploration of the TRAPPIST, one system marks another key focus of JWST. This stellar system, located 40 light-years from Earth, consists of 7 Earth-sized planets orbiting a red dwarf star. 3 of these planets lie within the habitable zone, where conditions might allow for liquid water. The TRAPPIST, one system, offers a unique opportunity for scientific discovery, raising the tantalizing possibility of life. As the James Webb Space Telescope continues its exploration, it faces formidable challenges. Proxima b, though only 4.25 light-years away, poses significant observational difficulties. Its tight orbit exposes it to intense stellar flares, complicating our ability to capture clear snapshots of the planet. Yet, JWST's advanced capabilities provide hope. The telescope stands as humanity's sentinel, sifting through starlight to unravel Proxima b's atmospheric composition, offering clues to its habitability and the potential presence of life. In the quest for understanding, future discoveries hold immense promise. Telescopes even more powerful than JWST are expected in the mid-2020s. These technological marvels could detect key atmospheric markers like ozone, offering compelling evidence of life or habitability across the universe. As we stand at the precipice of profound discoveries, we must confront the monumental philosophical implications of finding that we are not alone, or conversely, that we occupy a unique, solitary position in the cosmos. What do you think about this? If you found these facts intriguing or have thoughts to share, please let us know in the comments. Don't forget to give us a thumbs up and subscribe to A World to Discover. While you're here, feel free to click on other videos that appear on the screen right now. We physicists have waited 100 years, since 1916, for this photograph. Today, we're diving into one of the universe's most enigmatic phenomena, black holes. Did you know the journey to understanding these cosmic mysteries began over a century ago? Let's rewind to 1916, a pivotal year in physics. That year, Albert Einstein introduced the groundbreaking theory of general relativity. This set of equations laid the foundation for predicting something mind-boggling: black holes. In Einstein's universe, space and time are interwoven, warped by the mass of objects. Imagine the universe as a trampoline, with stars and planets as heavy balls creating dips and curves. Einstein's equations hinted at places where the fabric wasn't just curved, but punctured, creating a well so deep that not even light could escape. These were the theoretical black holes. Fast forward to the 1960s, when black holes moved from theoretical physics to observational astronomy. This shift happened in our own Milky Way, in the Cygnus constellation. The discovery of Cygnus X-1, the first identified black hole, confirmed Einstein's theories and opened a new chapter in astrophysics. Located 6,000 light-years away, Cygnus X-1 is an incredibly dense object with such strong gravitational pull that not even light can escape. This discovery validated Einstein's predictions in a tangible way. What was once theoretical physics had become observable astrophysical reality. What makes black holes fascinating is their immense gravitational pull, so intense that it warps space and time. Black holes are composed of three distinct layers: the event horizon, the point of no return, the photon sphere, where light particles orbit the black hole, and the singularity, a point of infinite density where all laws of physics collapse. Today, thanks to advancements in technology and our understanding of gravitational waves, scientists are beginning to unlock the secrets of these cosmic enigmas. Black holes are detected indirectly through their effects on nearby objects. For instance, the stars around Cygnus X-1 exhibit strange, rapid orbits, a telltale sign of a black hole's gravitational influence. Our own galaxy, the Milky Way, houses a supermassive black hole at its core, Sagittarius A*, giant 4 million times the mass of the Sun. We've observed stars orbiting this invisible giant at incredible speeds, a testament to the immense gravitational force at work. For years, capturing a direct image of a black hole seemed impossible due to their nature. How do you photograph something that swallows light itself? But in 2019, scientists achieved the unthinkable. Using a network of 8 ground-based telescopes spread across the globe, they created the Event Horizon Telescope, EHT, a virtual Earth-sized observatory. After years of work and hundreds of terabytes of data, they unveiled the first-ever image of a black hole's event horizon, a moment that shook the scientific community. This image of a black hole in the M87 galaxy, over 55 million light-years away, captured the intense gravitational warping around its event horizon. The black hole appears as a glowing, circular silhouette, proof of Einstein's theory in action. Looking ahead, the next frontier involves studying black holes at even higher resolutions and exploring the mysteries they hold. Are they wormholes to other dimensions? Could they be gateways to parallel universes? While we may not have all the answers yet, one thing is certain: black holes are not just astrophysical oddities. They are key to unlocking the deeper mysteries of the cosmos. Hole is born. Moving on to a more complex scenario, we encounter the Kerr solution, a fascinating twist in black hole theory proposed by mathematician Roy Kerr. This solution suggests that not all black holes are static. Imagine a black hole spinning at an incredible speed. This rotation leads to the formation of a ring of fire or a thin disk around the singularity, a region known as the ergosphere. Here, the laws of physics get even weirder as the black hole's spin drags the very fabric of spacetime along with it. This brings us over to wormholes. Wormholes in spacetime. Imagine spacetime as a two-dimensional sheet. Normally, we travel across this sheet to move from one point to another. But what if this sheet can fold, bringing distant points closer? A wormhole is like a tunnel that bridges this gap, a shortcut through the cosmos. The idea stems from Einstein's theory of general relativity, which allows for the bending and folding of spacetime under extreme conditions, such as those found near black holes. The concept of wormholes is a fascinating solution to Einstein's field equations. However, it's one thing to exist on paper and quite another in reality. One of the biggest challenges is stability. Theoretical models suggest that wormholes, if they exist, are incredibly unstable. As soon as any matter, even a single photon, enters a wormhole, it would collapse, making traversal impossible with our current understanding and technology. Despite these challenges, the idea of wormholes continues to be a subject of intense speculation and study. They raise questions about the fundamental nature of the universe and our place within it. Could wormholes be the key to interstellar or even intergalactic travel? Could they enable us to achieve what is currently beyond the realm of possibility? Superstring theory. One of the most ambitious and mind-bending concepts ever proposed is superstring theory. This revolutionary idea, explored by renowned physicists like Michio Kaku, seeks to weave together the fabric of our understanding of the universe. Superstring theory presents itself as a potential theory of everything, uniting Einstein's theory of gravity, which governs the cosmos, with quantum theory, which explains the behavior of the smallest particles in the universe. This unification has been a holy grail in physics, a quest to find a single framework that explains all fundamental forces and particles. At the heart of superstring theory is a beautifully simple yet profound idea. What if the fundamental particles we know, electrons, quarks, photons, are not point-like dots, but rather tiny vibrating strings? Each string's vibration determines the particle's properties, much like different notes emerge from different vibrations of a guitar string. Here's where it gets even more fascinating. Superstring theory proposes that the universe isn't limited to the 4 dimensions of space and time that we experience, 3 of space and 1 of time. Instead, it suggests there are 10 dimensions. These extra dimensions are thought to be compactified or curled up in such a way that they are imperceptible at our scale of observation. The existence of these extra dimensions could solve many mysteries in physics. For instance, they might explain why gravity is so much weaker than the other fundamental forces. In superstring theory, gravity's apparent weakness is because it spreads out through all 10 dimensions, while other forces are confined to the 4 dimensions we experience. The nature of the universe. In this segment, we delve deep into one of the most profound mysteries that has long captivated scientists and philosophers alike: the origins of our universe. Recent hypotheses have pushed the boundaries of our imagination, suggesting scenarios that sound like they're straight out of a science fiction novel. Let's begin with a mind-bending idea. What if our universe was born from the collision of 2 separate universes? Imagine 2 vast cosmic entities existing in a multiverse, colliding and merging in an event of unimaginable scale and energy. This cataclysmic interaction could have sparked the birth of the universe as we know it, creating the complex tapestry of galaxies, stars, and planets. Another intriguing theory proposes that our universe might have emerged from another universe. This concept is akin to a cosmic Russian doll, where universes give birth to new universes. It's a continuous cycle of creation, where each universe has its own laws of physics and properties, vastly different from its parent. Perhaps the most startling speculation is that our entire universe could actually be inside a black hole. This theory suggests that the singularity at the center of a black hole, rather than being a point of infinite density, could be the seed of a new universe. In this scenario, every black hole in our universe could potentially be a gateway to another universe. These theories also highlight the limitations of our perception. We experience the universe in 4 dimensions, 3 of space and 1 of time. But what if there are more dimensions, as suggested by theories like superstring theory? Our 4-dimensional perception might be just a slice of a much more complex, higher-dimensional reality. Continuing research and speculation, as we push the boundaries of our knowledge, the study of black holes could lead us to uncover new aspects of space-time, matter, and the very fabric of the universe. It's a journey that intertwines the vastness of the cosmos with the subatomic world, challenging our perceptions and theories. We hope you found these facts intriguing. If you've heard them before or have any thoughts to share, please let us know in the comments below. Don't forget to give us a thumbs up and subscribe to A World to Discover to join us on our journey of discovery. Now imagine looking on the horizon and sunrise covers half the sky. NASA has released images of a never-before-seen phenomenon where a star named Betelgeuse blew its top off and ejected a gigantic portion of its surface mass. The event is known as a surface mass ejection, SME, and according to the space agency, the ejection was 400 billion times the mass of an ordinary solar flare from our sun. Scientists termed the event as watching stellar evolution in real time. A star blasting off such huge chunks of its physical form has surprised many. The catastrophic explosion of this super-red giant is upsetting a lot of what we know in the universe. Why did Betelgeuse blow off its top? How will that affect the universe? Let's find out. Constellations are made up of many stars and are arranged in accordance with mythology and legends. They are still used for navigation today. One such star is Betelgeuse, which is among the largest and brightest stars in our night sky. The brilliant ruby-red, glittering star known as Betelgeuse is located in the upper right shoulder of the Winter constellation Orion the Hunter. When viewed attentively, though, astronomers recognize it as a seething monster with a 400-day-long heartbeat of regular pulsations. Because of its dismal orange-red color, Betelgeuse is easily identified. It's ideal for convincing doubters that stars do in fact have different colors. It is also known as Alpha Orionis, and is the second brightest star in the constellation after the blue supergiant Rigel. Betelgeuse is an intriguing object for star studies and observations due to its variable nature as well as its odd name. Frequently, stars with the name Alpha are the brightest stars in their constellations, even though Rigel, Orion's other bright star, is brighter. Vibrant blue or teeming with life will be transformed into a desolate barren rock, void of any life-sustaining water. This cataclysmic transformation will signify the end of the Earth's capacity to harbor life. The planet's atmosphere will be gradually stripped away, leaving its surface exposed to the scorching effects of the sun's radiation, turning it into nothing more than a scorched wasteland. This inevitable phase in the sun's life cycle serves as a stark reminder of the transient nature of celestial bodies and the ultimate destiny that awaits our planet. It underscores the profound impact of cosmic evolution on the fate of Earth, highlighting the impermanent nature of our world in the grand scheme of the universe. The Carrington Event, a historical perspective. In the midst of the 19th century, humanity stood witness to an extraordinary cosmic phenomenon that profoundly influenced our burgeoning technological landscape. This event, now known as the Carrington Event, occurred in the late summer of 1859, marking a significant milestone in the annals of space weather research. It derives its name from Richard Carrington, a dedicated British astronomer who meticulously documented the solar flare that was at the heart of this unprecedented event. On an unremarkable day, amidst his regular observations, Carrington observed an intense white light erupting from the surface of the sun. This was not merely a spectacle of light and energy. It was the harbinger of an immense geomagnetic storm that would reach Earth about 18 hours later. This storm unleashed a magnetic wave across our planet, the likes of which had never been documented in the annals of human history. The effects of this geomagnetic storm were both immediate and profound, particularly on the telegraph systems of the time. These systems, representing the pinnacle of communication technology in the mid-19th century, were ill-prepared for the solar storm's impacts. Telegraph operators were startled by papers catching fire, machines functioning without any external power, and electric shocks that rendered the telegraph network erratic or, in some cases, completely inoperative. This event served as a stark reminder of our technological vulnerabilities and the potential havoc that solar activity can wreak on human advancements. Modern dangers of solar flares. As we delve deeper into an era where technology is not just a part of our lives but the foundation upon which our modern society is built, the shadow of solar flares looms larger and more ominously than ever before. These natural phenomena, eruptions of immense energy from the sun, pose a significant threat to the technological infrastructure that underpins our way of life. Envision a scenario where our world is plunged into darkness, not just momentarily or for a few hours, but for an extended period that stretches into days, weeks, or possibly even longer. This scenario is not plucked from the pages of a science fiction novel, but represents a real and present danger in our technologically dependent age. The electrical grids, the lifelines of our civilization, are alarmingly susceptible to the destruction caused by solar flares. A substantial solar flare could unleash electrical currents powerful enough to destroy transformers and incapacitate power stations, casting vast swaths of civilization into an unwelcome return to darkness. The risks extend far beyond the vulnerabilities of our terrestrial infrastructure. The skies above, crowded with satellites integral to nearly every facet of modern life, from navigating our way through cities to the seamless flow of global communications, are at peril from the intense burst of energetic particles from solar flares, which can wreak havoc on satellite electronics, disturb the transmission of signals, and cause deterioration to these critical orbital assets. The potential for a domino effect of failures is real, with consequences that could cascade through every corner of our economy, disrupt emergency services, and affect many other critical aspects of our daily lives. Furthermore, our global communication networks, the very threads that weave together the fabric of our interconnected existence, stand on precarious ground. The impact of a solar flare could instantly sever these connections, disrupting the flow of information and communication on which we have become so dependent. A recent incident, a significant solar flare causing a moderate radio blackout over South America, starkly illustrates our system's vulnerability. Such events underscore the precariousness of our reliance on technology, highlighting how quickly our capabilities for communication, navigation, and digital operation can be disrupted. In this light, solar flares represent not just a natural curiosity but a formidable challenge to the resilience of our technological society, reminding us of the need for preparedness and protection against the causes of our sun. Solar observations and advances in astronomy. In the vast expanse of our universe, the sun has always been a focal point of human curiosity and scientific inquiry. Our journey into the realm of solar astronomy began in earnest in the early 18th century when astronomers first turned their telescopes towards the heavens, not just to map the stars but to study our own star's enigmatic and vibrant nature. This was a time when the field of solar astronomy was as straightforward as it was daring. Armed with nothing but their telescopes and the naked eye, early astronomers began to peel back the layers of the sun's blazing facade. The sun, a seemingly eternal flame in the sky, revealed its secrets slowly. By simply observing its light, early scientists learned volumes. They used prisms to dissect the sunlight into its many wavelengths, unveiling a spectrum that stretched from the ultraviolet to the visible and into the infrared. They discovered sunspots and solar flares, dark and light phenomena that danced across the solar surface, hinting at the immense energy and complex processes at play. These initial observations laid the groundwork for our understanding of the sun and its impact on Earth. As the centuries progressed, so too did our technological prowess. The advent of the telescope brought the cosmos closer, but it was the evolution of solar observatories and space-based telescopes that marked a new era in solar astronomy. The mid-20th century saw the launch of the first satellites dedicated to observing the sun, providing a vantage point unobstructed by Earth's atmosphere. This was a quantum leap forward, offering us a continuous view of our star in multiple wavelengths, day and night. In the 21st century, our quest to understand the sun has led to the development of cutting-edge observatories equipped with instruments so precise they can measure the magnetic fields and plasma flows of the sun's surface and beyond. The Daniel K. Inouye Solar Telescope, for instance, stands as a titan among these modern marvels. With its unparalleled resolution, it allows us to observe the sun's magnetic field in exquisite detail, offering insights into phenomena like solar flares and coronal mass ejections with unprecedented clarity. Moreover, the Parker Solar Probe, launched in 2018, is on a daring mission to touch the sun. Well, almost. It aims to travel closer to the sun's surface than any spacecraft before it, braving extreme temperatures and radiation to gather data that could solve long-standing mysteries about the sun's corona and its influence on space weather. The threat of coronal mass ejections. In the cosmic dance of celestial forces, the sun plays a pivotal role, not just as the source of light and life, but also as a harbinger of potentially catastrophic phenomena. Among these are the coronal mass ejections, or CMEs, vast expulsions of plasma and magnetic fields from the sun's corona, the outermost part of the sun's atmosphere. While solar flares are intense bursts of radiation that can light up the Earth's sky with dazzling auroras, CMEs are a different beast altogether. They release huge bubbles of gas and magnetic fields into space. When these bubbles strike the Earth, they can cause geomagnetic storms capable of wreaking havoc on our planet's magnetic field. The difference between solar flares and CMEs is not just in their nature, but also in their impact. While solar flares affect Earth's atmosphere in the form of electromagnetic radiation, CMEs carry with them the physical matter from the sun, which can interact with Earth's magnetic field in more profound ways. This interaction can lead to severe disturbances in the geomagnetic environment, known as geomagnetic storms. The potential for CMEs to cause extensive damage to Earth's infrastructure is not a matter of speculation, but a reality we have glimpsed in historical events. The charged particles from these ejections can induce electric currents in power lines, leading to widespread power outages and damaging transformers, and other vital components of the electrical grid. In an age where our society is ever more dependent on technology and electrical power, the threat posed by CMEs extends beyond mere inconvenience. A powerful enough CME could disrupt communication networks, GPS systems, and even lead to the failure of critical infrastructure such as water supplies and transportation systems. The Sun's magnetic field and its effects. The Sun's magnetic field is a complex and dynamic feature. Far from being a uniform or stable presence, it comes to life due to the roiling convective movements of plasma that churn beneath the Sun's surface, creating a magnetic field that is both powerful and changeable. This field is at the heart of the Sun's periodic bursts of energy, which we see as solar flares and coronal mass ejections, CMEs. However, the mechanism that triggers these powerful events is a subject of fascination and study. At the core of these explosive phenomena is the process known as magnetic reconnection. To visualize it, think of the Sun's magnetic field lines as strands of energy that are constantly moving, intertwining, and evolving. Occasionally, these lines can break and then reconnect in different arrangements. When they do, they release a tremendous amount of energy in a short time. Magnetic reconnection acts as the trigger for solar flares and is the force that launches CMEs into the vastness of space. The impact of these solar events goes well beyond the confines of the Sun. Solar flares emit intense radiation that can disturb the Earth's atmosphere, leading to disruptions in satellite operations and communications networks. The threats from CMEs are even more significant. These gigantic clouds of plasma, when thrown into space, can have dramatic effects if the Earth is in their trajectory. The consequences range from the creation of spectacular auroras to intense geomagnetic storms. Such storms have the potential to damage our electrical grids and technological systems, highlighting the profound influence of solar activity on our daily lives and the technology we depend on. The latest solar flare event. In an unexpected twist in the saga of celestial phenomena, the Sun recently demonstrated its formidable power by releasing its strongest solar flare in almost 2 decades, an event that has become a landmark in the study of solar activities. This massive explosion of electromagnetic energy, categorized as an X2.8 class flare, has not only riveted the global astronomical community but also highlighted the Sun's capricious nature. Originating from a dynamic sunspot labeled AR 3514, the flare blasted through the cosmos, serving as a vivid testament to the immense influence of solar phenomena on our technological realm. The effects of the solar flare were swiftly felt on Earth, manifesting as a moderate radio blackout across South America. This incident served as a stark indication of our fragile, standing in the face of the Sun's unpredictable temperament. Moreover, the solar event adorned the skies with magnificent auroras, which stretched well beyond their usual geographic bounds, providing a stunning spectacle of natural beauty. Despite the awe-inspiring visuals, these occurrences bear a cautionary note regarding the potential disruptions that such solar activities pose to our deeply interconnected global systems, reminding us of the delicate balance between technological advancement and cosmic forces. Preparing for future solar storms. In anticipation of future solar storms, scientists and researchers have embraced a comprehensive strategy that includes early detection, a deeper understanding of solar phenomena, and the development of effective mitigation plans. This strategic approach is greatly supported by the deployment of cutting-edge solar observatories, which have vastly enhanced our capability to predict and brace for solar events. Among these advancements, the National Science Foundation's Daniel K. Inouye Solar Telescope stands out as a significant milestone in our observational efforts. Equipped with the latest scientific instruments, including 4 spectropolarimeters designed to measure the Sun's magnetic properties, the KIST offers invaluable insights into the intricate magnetic field of the Sun's corona, chromosphere, and photosphere. These state-of-the-art observatories play a crucial role beyond mere observation. They act as an advanced early warning system for our planet. By analyzing the magnetic field of coronal mass ejections, CMEs, at the moment they occur, scientists can determine the direction and potential impact of these charged particles. This is vital for assessing whether the ejected material will pose a threat to Earth. Armed with this knowledge, we can predict the arrival of solar storms well in advance, providing a precious window for taking protective measures. These measures are aimed at safeguarding critical infrastructure, including our electrical grids, communication networks, and satellites from the potentially devastating effects of solar storms. Moreover, the focus on developing and refining predictive models of the sun's behavior has become increasingly important. These models, powered by the wealth of data collected by solar observatories, are crucial for improving our understanding of solar dynamics. Sure, enable scientists to predict solar activities and storms with a higher degree of accuracy, making it possible to anticipate and mitigate the impact of these celestial events on Earth. This multifaceted approach exemplifies the proactive steps being taken to protect our planet from the powerful forces of our closest star, ensuring a higher level of preparedness for future solar phenomena. In confronting the unpredictable fury of solar storms, humanity's resolve shines as brightly as the phenomena we seek to understand. Leveraging advanced observatories and scientific ingenuity, we stand prepared not just to withstand the sun's might but to thrive in its presence. This commitment to foresight and resilience illuminates our path forward, ensuring that as we gaze up at the cosmos, we do so not with fear, but with the confidence of those ready to meet the future. We hope you found these facts intriguing. If you've heard them before or have any thoughts to share, please let us know in the comments below. Don't forget to give us a thumbs up and subscribe to A World to Discover to join us on our journey of discovery. While you're still here, feel free to click on other videos you will see on the screen right now. Looks like going to the moon one day and to Mars, and to get to Mars, they're going nuclear. Imagine a world in which we are no longer limited by space and can traverse the enormous cosmic distances that previously seemed unbridgeable. Imagine spacecraft traveling faster than the speed of light as they dart across the stars, a concept that piques our curiosity and fuels our desire to explore beyond Earth. Science fiction no longer exists in this domain. Scientists are about to make discoveries that could lead to travel faster than the speed of light. We are on the verge of transforming the fantastical into the real, capable of stretching the boundaries of space and time and exploring theoretical possibilities that defy basic physics. They call the action which is to do with the mass of the particle, the time, and the distance, so you basically calculate these little quantities. But how much closer are we really to crossing this last obstacle? To what extent is science fiction already becoming science fact? Imagine being able to travel through space faster than the speed of light by boarding a spacecraft that looks like it belongs in your favorite action film. Once limited to fiction, this ambition is becoming more and more true, thanks to the idea of warp drives, a speculative idea that might completely change space travel. The fundamental tenet of this project is a daring rejection of one of the most widely accepted theories in physics, Einstein's claim that nothing can travel faster than the speed of light. In accordance with Einstein's theories of relativity, an object's mass increases exponentially as it gets closer to the speed of light and needs an endless supply of energy to move forward. Humanity has long been forced to travel across the vast reaches of space at the glacial rate of conventional propulsion because of this barrier, which appears to be insurmountable. This brings us to the Alcubierre drive, an idea that originated in physicist Miguel Alcubierre's academic endeavors rather than science fiction. Alcubierre proposed a method that bends space-time itself, rather than trying to exceed the cosmic speed limit. Drawing inspiration from the visionary leaps of science fiction, imagine compressing space in front of a spaceship and extending space behind it, all while enclosing it in a bubble of flat space-time. By staying in a pocket of space unaffected by relativity, this manipulation allows the spaceship to travel ahead and ride the wave of warp space-time at effective speeds faster than light. Unquestionably enchanting, the Alcubierre drive offers a ticket to the skies. However, there are many theoretical and practical obstacles in the way of turning an idea into reality. Because the drive needs exotic matter or negative energy, it operates at the edge of physics. The existence of such materials is still up for debate. Furthermore, this innovative kind of transportation is beyond the reach of existing technology due to the enormous amounts of energy required to control spacetime on this scale. The Alcubierre drive technology, in spite of difficulties, symbolizes human inventiveness and our unwavering desire to explore, signaling the beginning of star-crossing expeditions as a tribute to our boundless potential and the ever-expanding boundaries of knowledge. Let me know if you need further adjustments. The character of the space race was characterized by amazing achievements made in the shadow of competition. The Soviet Union's covered Mars mission revealed a new chapter in space exploration history, offering a platform for not just rivalry but also exploration and amazement beyond our planet's boundaries. The enduring legacy of the covered Cold War Mars missions demonstrates human ambition and curiosity, serving as a constant reminder of the infinite potential of space and motivation for our ongoing exploration of the unknown. The future of interstellar travel and Mars colonization holds endless prospects as we approach the dawn of a new age in space exploration. The greatest minds in theoretical physics are currently delving into the unrelenting quest for faster-than-light travel, which was formerly limited to science fiction books. Visionaries such as Miguel Allure have promoted the idea of bending space-time to our whim, offering an alluring portal to the stars. Researchers like Eric Lent and Harold Sonny White are working hard to make the warp drive a reality, and it is no longer just a sci-fi fantasy. These developments portend a time when light-year-long travel distances could be completed in the blink of an eye. Concurrent with the aspiration to surpass the speed of light is the grand project of settling on Mars. For many years, the red planet has captured the attention of people due to its bleak beauty and the possibility of fresh starts. In addition to offering priceless insights into the temperature, geology, and possibility of life on Mars, recent missions have established the foundation for human habitation. The combination of private companies like SpaceX, led by Elon Musk, and international space agencies is driving the dream of Mars colonization ahead. Musk hopes to establish a long-term human presence on the planet during our lifetimes. This joint effort represents a cosmic giant leap for humanity, similar to the evolution from hunter-gatherer tribes to agricultural civilizations. Still, the trip to Mars is only the start. The possibility of exploring space beyond Mars and into the larger galaxy is becoming more and more realistic as our knowledge of science and technology advances. The finding of exoplanets in habitable zones around far-off stars has created new opportunities for research and possibly even habitation. These celestial bodies might provide new places for humans to live, assuring our survival and the continuance of our galactic exploration and learning endeavors. In conclusion, the prospect of Mars settlement and interstellar travel serves as a constant reminder of our enduring urge to explore the unknown. In addition to serving as a monument to human creativity and tenacity, the opportunities are endless as we approach the edge of this new territory. The stars are lighthouses pointing us in the direction of our destiny amid them, not merely spots of light in the night sky. Although the road ahead is full of obstacles, we approach it with hope and the unwavering spirit of discovery that makes us who we are, not on Earth, but in the dusty red soil of Mars and beyond. Into the wide, unexplored reaches of our cosmos lies the next chapter in the history of humanity. The universe is teeming with planets outside our solar system, and each one offers a unique glimpse into the vast complexities of space. Enter the James Webb Space Telescope, JWST, a marvel of modern science and a beacon of hope for astronomers searching for Earth-like planets. The JWST, with its unparalleled ability to peer into the depths of space through infrared eyes, has transformed our quest to understand distant worlds. Today, we're diving deep into one of JWST's most thrilling revelations yet, the discovery of GJ-163c. This exoplanet, located in the habitable zone of its star, presents conditions that might just support life as we know it. GJ-163c is not just another celestial body. It represents a potential future, a new chapter in human exploration, and perhaps the answer to the age-old question: are we alone in the universe? The James Webb Space Telescope stands as a pinnacle of astronomical technology, equipped with tools specifically designed to observe distant exoplanets with unprecedented clarity and depth. Among its suite of sophisticated instruments, the near-infrared camera, an IR-CAM, is pivotal. An IR-CAM not only captures detailed images of exoplanets, but also analyzes their atmosphere by observing the light passing through it when a planet transits its star. This helps identify elements that might indicate habitable conditions or even the presence of life. Another groundbreaking instrument aboard the JWST is the Mid-Infrared Instrument, MIRI. MIRI extends the telescope's vision further into the infrared spectrum, which is crucial for studying cooler celestial objects. This capability is vital for examining the thermal characteristics of an exoplanet, providing insights into its surface temperature and conditions that are essential for assessing habitability. Equally important, the Near-Infrared Spectrograph, NIR-SPEC, allows astronomers to dissect the chemical makeup of an exoplanet's atmosphere by spreading out the starlight into a spectrum. This tool can detect water vapor, methane, and other organic compounds, offering clues about the potential for life as we understand it. With these advanced tools, the James Webb Space Telescope not only seeks to find exoplanets, but also to explore them in a depth that was previously unimaginable, bringing us closer than ever to understanding whether planets like GJ-163c could truly be called Earth's cousins. The discovery of GJ-163c made headlines, quickly capturing the attention of astronomers and space enthusiasts alike. This significant find was announced after JWST's detailed analysis of the star system GJ-163, located about 49 light-years away in the constellation Dorado. Using its advanced near-infrared spectrograph, JWST was able to detect the chemical signatures and thermal properties that suggest GJ-163c might be within the star's habitable zone. Initial observations of GJ-163c indicated several exciting possibilities. The planet's orbit places it at just the right distance from its star to potentially allow liquid water to exist on its surface, an essential criterion for Earth-like life. Moreover, the spectral data revealed hints of an atmosphere, which is another critical factor in considering the habitability of a planet. These early findings have laid the groundwork for more detailed studies, making GJ-163c a prime candidate in the search for life beyond Earth. When scientists search for potentially habitable planets like GJ-163c, they primarily focus on three critical criteria: atmosphere, temperature, and the presence of water. Each of these elements plays a pivotal role in supporting life as we understand it. Firstly, an atmosphere is crucial because it can regulate temperature, protect biological entities from cosmic and solar radiation, and provide essential gases that biological processes might require. For instance, an atmosphere rich in oxygen and nitrogen like Earth's can support aerobic life forms and water cycles. Secondly, the temperature of a planet is equally significant. It must be neither too hot nor too cold, enabling the existence of liquid water on the planet's surface. This Goldilocks zone is where temperatures are just right for liquid water to exist, not so cold that it freezes solid and not so hot that it vaporizes away. Finally, the presence of water is often considered a key marker for life. Water is a solvent in which biochemical reactions occur, crucial for life on Earth. Thus, finding signs of water on GJ-163c, whether in vapor form in the atmosphere or as liquid on the surface, would be a strong indicator that the planet could potentially be hospitable to life forms. These criteria guide astronomers as they use the JWST to observe planets across the galaxy, searching for those rare worlds where conditions might just be right for life to emerge. GJ-163c stands out in the cosmic lineup of exoplanets due to its intriguing characteristics. It orbits its host star GJ-163 at a distance that places it squarely within the star's habitable zone, which is the region where conditions might be just right for liquid water to exist on the planet's surface, a crucial factor for life as we understand it. The planet is approximately 6.9 times the mass of Earth, classifying it as a super-Earth. This size suggests a rocky composition with a more substantial atmosphere than our home planet, which could lead to a greenhouse effect potentially warming the planet. The orbit of GJ-163c is particularly fascinating. It completes a full revolution around its star in approximately 26 Earth days. Such a short orbital period indicates that the planet is much closer to its star than Earth is to the Sun. However, because GJ-163 is a red dwarf and much cooler than our Sun, this proximity places GJ-163c in the sweet spot for temperate conditions. Comparatively, Earth orbits the Sun every 365 days, reflecting our moderate distance from a much hotter star. The environmental conditions on GJ-163c, inferred from its orbit and size, suggest a world that could host thick atmospheric layers capable of trapping heat. If water exists, its state, whether vapor, liquid, or ice, would heavily depend on atmospheric composition and surface pressure. In contrast, Earth's well-balanced atmosphere and magnetic field have created a stable environment where water can exist in all three states, supporting a diverse range of life forms. As we continue to study GJ-163c, understanding these key differences and similarities will help scientists better assess the planet's potential for habitability and life. The James Webb Space Telescope leverages cutting-edge technology to unveil the secrets of distant worlds like GJ-163c. Central to its success are several key instruments, each playing a vital role in this cosmic detective work. The Near-Infrared Camera, NIRCam, is JWST's primary imager, capturing high-resolution images that bring distant stars and their orbiting planets into clearer view than ever before. This capability is crucial for spotting minute changes in brightness and position that hint at the presence of exoplanets. Additionally, the Mid-Infrared Instrument, MIRI, provides new insights into the thermal characteristics of GJ-163c, allowing scientists to gauge the planet's heat emission and infer surface temperatures. MIRI's deep infrared observations are vital for detecting cooler objects and understanding their thermal signatures, offering clues about the planet's climate and atmospheric composition. Equally essential is the Near-Infrared Spectrograph, NIR-SPEC, which breaks down the light from exoplanets into its constituent spectra. This detailed analysis reveals the presence of specific chemicals in the planet's atmosphere, such as water vapor, methane, and carbon dioxide, key indicators of potential habitability. Using these advanced tools, the JWST can create detailed atmospheric profiles and surface maps, enhancing our understanding of GJ-163c's environment. This comprehensive approach to analyzing exoplanets marks a significant advancement in our quest to find potentially habitable worlds and perhaps even detect signs of extraterrestrial life. The collaborative work of these instruments positions JWST at the forefront of astronomical research, opening new doors in the study of planets beyond our solar system. In sum, the James Webb Space Telescope represents a quantum leap in our ability to explore and understand distant exoplanets like GJ-163c. By employing its suite of sophisticated instruments, astronomers are able to delve deeper into the mysteries of these celestial bodies, providing unprecedented insights into their composition, climate, and potential for hosting life. As we continue to analyze data from JWST, the hope of finding a new Earth-like world becomes more tangible, fueling our collective curiosity and expanding the horizons of human knowledge. It expands our understanding of habitability and tight solar orbits, but also deepens the mystery surrounding these distant worlds. Such a discovery redefines not just the search for extraterrestrial life, but also the very parameters of what to look for in the cosmos. The implications of this could be profound, reshaping our search strategies and targets in the ongoing quest to find alien life. As we continue to investigate these signals, we edge closer to perhaps one day confirming the existence of other technologically advanced civilizations in the universe. Delving into Proxima B's atmosphere, the atmospheric study of Proxima B via the James Webb Space Telescope offers a rare window into conditions on a potentially habitable exoplanet. Given the high sensitivity of James Webb's instruments, astronomers can discern subtle variations in the planet's atmosphere, providing insights into its climate and chemical makeup. Proxima B's proximity to its star could lead to extreme atmospheric conditions, including high radiation levels and significant temperature variations between its day and night sides. This makes understanding its atmospheric stability and composition even more critical. Researchers focus on identifying key molecules like water vapor, carbon dioxide, and methane, which are considered essential for supporting life as we understand it. The presence of these molecules can indicate active geological or chemical processes similar to those on Earth, which could sustain an environment conducive to life. For instance, water vapor is a telltale sign of potential hydrological cycles, and methane could suggest organic activity. These detailed observations also help in modeling Proxima B's potential ecosystems and assessing how its environment has evolved over time. Are these conditions stable enough to support life? Does the atmosphere protect the surface from harmful stellar radiation? Each data point collected by the James Webb Space Telescope helps to build a more comprehensive picture of Proxima B's habitability. Ultimately, while the search for alien life is captivating, it is the meticulous study of atmospheres like that of Proxima B that grounds such searches in scientific rigor. This ongoing research not only enhances our understanding of distant worlds, but also refines our knowledge of planetary science, a critical step toward answering the age-old question of whether we are alone in the universe. The philosophical implications of discovering alien life exploring Proxima b transcend the scientific ambition of discovering alien life. It taps into a deeper, almost philosophical yearning that has shadowed humanity throughout history. This exoplanet, nestled in the habitable zone of the nearest star to our solar system, serves as a canvas on which we project our grandest existential inquiries. As astronomers pass through data collected by instruments like the James Webb Space Telescope, each piece of information offers a potential clue not just about the conditions on Proxima b, but also about the broader cosmic landscape that surrounds us. The implications of finding life, or habitable conditions there, are monumental. They would suggest that life-sustaining planets could be more common than previously thought, thereby increasing the probability that the universe teems with life. This prospect shifts our understanding of life's rarity and resilience, prompting us to reconsider our role and significance in the grand scheme of existence. Are we just a cosmic anomaly or part of a broader, perhaps infinite, tapestry of life forms? Such questions have philosophical weight, influencing everything from the search for extraterrestrial intelligence, SETI, to theoretical physics and existential philosophy. The study of Proxima b isn't just a quest for biological signatures or atmospheric analysis. It's a bridge to understanding the universe's capacity to harbor life, challenging our perceptions of loneliness and connectivity in the cosmos. In essence, as we decode the mysteries of Proxima b, we are also unraveling the narrative of human significance in an expansive, dynamic universe. The answers we find could redefine our place in the cosmos as not merely solitary travelers, but potentially as part of a much larger community of cosmic inhabitants. Breakthrough Listen, Searching for Signals of Intelligent Life, is a pioneering initiative funded by ambitious visionaries that utilizes state-of-the-art radio telescopes to eavesdrop on the universe. Its primary goal is to capture electromagnetic signals that could indicate the presence of intelligent civilizations beyond Earth. Recently, their focus has turned toward Proxima b after detecting a narrowband radio signal originating from its vicinity. This signal, peculiar due to its specific frequency pattern, closely resembles what we'd expect from a technologically advanced source. While it's far from confirmed as extraterrestrial, this development excites scientists and the public alike, as it may potentially shift our understanding of life in the universe. Each signal captured is rigorously analyzed to differentiate between possible interstellar communications and cosmic noise, ensuring that only the most promising are considered. This tantalizing glimpse into the cosmic landscape not only advances the field of astrobiology, but also deepens the enigma surrounding our nearest stellar neighbor. Such findings promise to catalyze further research, holding the potential to one day break the silence of the cosmos. Proxima b's rapid orbit and its environmental challenges present a unique dynamic. Proxima b's rapid orbit of just 11.2 days around its host star implies that a year on Proxima b passes in what would be less than 2 weeks on Earth, drastically altering how we must approach the study of its seasons and weather patterns, if such exist. Given its potential tidal locking, where one side is perpetually day and the other eternally night, understanding atmospheric circulation becomes crucial. Scientists hypothesize that if an atmosphere does exist, it could be the key to transferring heat between these two extremes, potentially allowing for a more temperate climate in the twilight zone between the harsh environments of the bright and dark sides. Such a study could offer insights into not only the climate and weather patterns on Proxima b, but also broaden our understanding of atmospheric sciences in extreme exoplanetary conditions. This could, in turn, deepen our knowledge of planetary habitability across the universe, revealing how life might adapt to conditions vastly different from those on Earth. Navigating the challenges of a hostile star, exploring the habitability of Proxima b brings us face to face with the volatile nature of its host star, Proxima Centauri, an M-dwarf. These stars, while abundant in our galaxy, present unique challenges for planetary habitability. M-dwarfs are notorious for their violent solar flares, which can be much more frequent and powerful compared to those from our Sun. Such flares emit intense radiation that has the potential to strip away the atmosphere of planets in close orbits like Proxima b. This atmospheric stripping is critical because an atmosphere not only supports life as we know it, but also protects the surface from harmful cosmic and solar radiation. Further complicating the scenario, M dwarfs remain active longer than larger stars, meaning Proxima b is exposed to these harsh conditions for extended periods, potentially billions of years. This prolonged bombardment by solar radiation could hinder the development or sustainability of life, as continuous flare activity might prevent the planet from maintaining a stable atmosphere long enough for life to develop or sustain itself. Moreover, the high-energy particles from Proxima Centauri could erode the atmosphere's ozone layer, if one exists, increasing the surface's exposure to deadly ultraviolet light. Without an ozone layer, any life forms would be vulnerable to radiation that could mutate DNA, posing another hurdle for life. These factors make the environment of Proxima b appear hostile. However, the resilience of life on Earth in extreme conditions gives us a glimmer of hope that life could adapt in ways we haven't yet imagined. Proxima b continues to captivate our curiosity and drive our exploratory efforts, each discovery bringing us closer to understanding not just other worlds, but also our own planet's resilience and the tenacity of life itself. Advanced tools for a deeper understanding, the James Webb Space Telescope, JWST, equipped with cutting-edge technology such as the Near-Infrared Spectrograph, NIR-SPEC, and the Mid-Infrared Instrument, MIRI, is revolutionizing our study of distant planets. These instruments are not just cameras or telescopes. They are finely tuned analytical tools that break down the complexities of distant worlds, light into its spectral components. This process, known as spectroscopy, allows scientists to detect specific signatures of gases and other materials present in the atmosphere of Proxima b. NIR-SPEC, for example, operates in the near-infrared spectrum and can detect the faintest whispers of light coming from distant celestial objects. It analyzes the light that passes through or is emitted by a planet's atmosphere, capturing data that can reveal the presence of water vapor, methane, carbon dioxide, and other potential markers of life. This capability is vital because these compounds can suggest biological processes similar to those on Earth. MIRI complements NIR-SPEC by focusing on the mid-infrared spectrum, which is especially good for studying cooler objects in space. It helps astronomers study the thermal properties of Proxima b, including its temperature variations and heat distribution, which are crucial for understanding the planet's climate and weather systems. MIRI can also see through dust clouds that obscure other instruments, providing a clearer picture of the planet's surface and atmosphere. Together, these instruments provide a comprehensive view of Proxima b's atmospheric makeup and surface conditions, offering insights into whether the planet could support life as we know it. Each new piece of data brings us a step closer to understanding not just Proxima b, but the characteristics that make any planet potentially habitable. The ongoing research with JWST instruments is gradually filling the gaps in our knowledge about Proxima b's environment, promising to eventually unlock the secrets of this intriguing world. A testament to human advancement in technology, the James Webb Space Telescope, JWST, stands as a monumental achievement in our quest to understand the cosmos. Equipped with a suite of sophisticated instruments, it peers into the farthest reaches of the galaxy with unprecedented clarity. This telescope uses infrared technology to bypass the dust and gas clouds that obscure other telescopes' views, allowing us to observe the formation of stars and planets in real time, examine the chemical composition of alien atmospheres, and possibly detect signs of life by identifying atmospheric anomalies that cannot be explained by natural processes alone. One of the most intriguing capabilities of the JWST is its potential to observe the atmospheres of distant exoplanets in such detail that we can identify the molecular signatures of water vapor, methane, and carbon dioxide. These molecules are often considered potential indicators of biological processes. By comparing these findings with our own planet's biosignatures, scientists hope to uncover parallels that might suggest similar life-sustaining conditions elsewhere in the universe. This ability to look back in time and out across space provides a clearer picture of our own origins as well. By examining other solar systems at various stages of development, we gain insights into the past and future of our own planetary system. The James Webb Space Telescope not only expands our understanding of the universe, but also serves as a mirror reflecting the possible trajectory of our own planetary destiny. With each mission and observation, JWST is rewriting textbooks on astronomy and possibly biology, bringing us steps closer to solving the ultimate mystery of our existence in this expansive universe. Expanding our cosmic horizons, the exploration of Proxima B transcends traditional astrophysics, venturing into philosophical realms. As we ponder our place in the cosmos, studying this exoplanet, particularly within its star's habitable zone, confronts the profound possibility of encountering extraterrestrial life forms. This endeavor not only sharpens our technological prowess, but also deepens our existential inquiries. By analyzing the atmospheric conditions and potential biological signatures on Proxima b, we contribute to a broader understanding of what environments can sustain life. Each discovery here influences our approach to other celestial bodies and adjusts our theories about life's prevalence in the universe, encouraging a broader reconsideration of biological possibilities beyond Earth. This ongoing research could eventually lead to a revolutionary paradigm shift in how we perceive life and intelligence in the universe. The journey of discovery continues. Now, let's conclude. The exploration of Proxima b is not just a scientific endeavor but a journey that taps into the human spirit of discovery, pushing the boundaries of technology, knowledge, and our understanding of life itself. As we peer deeper into the cosmos, each finding adds a new piece to the puzzle of our universe, ever expanding the horizons of human discovery. So, a new discovery in Antarctica. Researchers find new life under an ice shelf, and the discovery was an accident. Wow! The last remaining territory on the planet that could have such a designation is Antarctica. In the depths of Antarctica, where the cold is bone-chilling and the wind bites with relentless ferocity, lies a continent veiled in mystery and wonder. Antarctica, Earth's southernmost frontier, is a place of extremes where towering icebergs carve through frigid waters and endless expanses of snow and ice stretch as far as the eye can see. But beyond its harsh and unforgiving landscape, Antarctica holds secrets that have captured the imagination of explorers, scientists, and dreamers alike. What lies beneath the ice-covered surface of this remote continent? Could ancient civilizations or hidden alien bases lurk in the frozen depths, waiting to be uncovered? What clues to the origins of life on Earth might be hidden within the pristine ice cores that have accumulated over millennia? And perhaps most tantalizing of all, could Antarctica hold the key to unlocking the mysteries of the universe, offering insights into the existence of extraterrestrial life? A land beyond imagination, Antarctica, the southernmost continent on Earth, stands as an unparalleled realm of extremes, vastly exceeding the size of the United States by over 1.5 times. This continent is uniquely situated within the confines of the Antarctic Circle. This geographic positioning subjects Antarctica to the most dramatic of seasonal contrasts, plunging it into months of unyielding darkness during the winter months, then flipping the script to bathe it in continuous daylight throughout the summer. It's a land where the sun either barely rises above the horizon or doesn't set at all, depending on the time of year, creating an environment that seems almost otherworldly. This continent is not just remarkable for its light phenomena, but also for being the coldest, windiest, and driest place on Earth. Its vast expanses are blanketed in ice, harboring 90% of the planet's freshwater ice, which is a stark testament to nature's formidable power and dominance. The ice sheets, some stretching over thousands of miles, serve as a frozen archive, preserving the Earth's climatic history within their layers. Despite its freezing conditions, with temperatures that can plummet below -80 degrees Celsius, -112 degrees Fahrenheit in the winter, Antarctica is classified as a desert. Its inner regions receive a mere 2 inches of precipitation per year, significantly less than the Sahara Desert, making it the driest continent. This minimal precipitation fails to penetrate the thick ice, instead accumulating layer upon layer, contributing to the ice sheet's monumental growth. Antarctica's desolate landscape is sporadically disrupted by ferocious blizzards, which, unlike typical storms, derive their strength not from moisture but from the continent's powerful winds. These winds, capable of reaching speeds in excess of 200 miles per hour, whip up the snow from the surface, creating whiteouts that can distort, orient, and challenge even the most seasoned explorers. These conditions create a realm where survival is a testament to resilience and adaptation, hosting only the hardiest of life forms, such as microorganisms found in subglacial lakes and occasional visitors like penguins and seals along its coastlines. Yet beneath its inhospitable and icy exterior, Antarctica is a treasure trove of scientific marvels and a magnet for explorers, researchers, and scientists. These individuals are driven by an innate curiosity and a relentless pursuit of knowledge, braving the extreme conditions to uncover the secrets hidden beneath the ice. The continent serves as a natural laboratory for a plethora of scientific fields, including glaciology, meteorology, oceanography, and even astrobiology. Research conducted in this icy wilderness offers invaluable insights into Earth's past climates, enabling scientists to piece together the planet's environmental history and gain a better understanding of climate change. The Antarctic ice cores, in particular, are crucial for this research, containing air bubbles that are tiny time capsules providing snapshots of the Earth's atmosphere over hundreds of thousands of years. Moreover, the extreme conditions of Antarctica are ideal for conducting experiments and research that would be impossible elsewhere. The continent's isolation and the absence of human-induced pollution create a pristine environment for studying the cosmos, leading to significant advancements in space science and astrophysics. The clear, dry air offers unparalleled conditions for telescopic observations of the stars, planets, and galaxies, furthering our understanding of the universe. Antarctica's unique ecosystem and its extremophiles, organisms that thrive in the harshest environments, also offer scientists a glimpse into the resilience of life, posing intriguing questions about life's potential on other planets. The discovery of these life forms in such extreme conditions expands our understanding of the limits of life on Earth and beyond, contributing to the ongoing search for extraterrestrial life. In essence, Antarctica, with its majestic icebergs, its mysterious subglacial lakes, and its vast, untouched wilderness, stands as a beacon of exploration and scientific inquiry. It challenges the human spirit to venture into the unknown, to endure, and to discover, reminding us of the vast mysteries that still await us on our own planet. The continent's extreme conditions, rather than deterring human curiosity, have only fueled it, driving us to push the boundaries of exploration and knowledge further than ever before. Echoes of the past, discovery, and exploration. The saga of Antarctic exploration stretches back through the annals of human history, echoing with the whispers of ancient speculation and the thunderous roars of modern expeditions. For centuries, the notion of a vast southern landmass, a terra australis incognita, tantalized the imaginations of philosophers, cartographers, and adventurers alike. From the musings of ancient Greek scholars to the early voyages of European navigators, the quest for this elusive continent persisted, shrouded in myth and mystery. In the ancient world, philosophers such as Aristotle and Ptolemy speculated about the existence of a southern landmass to balance the known continents of the northern hemisphere. This conjecture, though rooted in rudimentary understanding and mythological beliefs, laid the groundwork for centuries of exploration and discovery. However, it wasn't until the dawn of the 19th century that the veil of mystery surrounding Antarctica began to lift. In 1820, the Russian expedition led by Fabian Gottlieb von Bellingshausen and the British expedition under the command of Edward Bransfield made the first confirmed sightings of the continent, dispelling centuries of speculation and myth. These pioneering voyages, fraught with peril and hardship, marked the beginning of a new chapter in human exploration. The subsequent decades saw a flurry of expeditions as nations vied for supremacy in the race to conquer the last frontier. Among the most renowned figures of this era were Ernest Shackleton and Robert Falcon Scott, whose names are etched into the annals of Antarctic history with tales of heroism and tragedy. Shackleton's legendary Endurance expedition, which aimed to traverse the continent where the South Pole ended in disaster when a ship became trapped in the ice, ultimately leading to a miraculous tale of survival against all odds. Scott's ill-fated Terra Nova expedition, while falling short of its goal to be the first to reach the South Pole, nevertheless immortalized the spirit of Antarctic exploration through his poignant journals and tragic demise on the return journey. The establishment of permanent research bases in the 20th century heralded a new era of Antarctic exploration, one focused not solely on conquest but on scientific inquiry and international cooperation. These bases, scattered across the icy expanse of the continent, serve as outposts of human endeavor where researchers from around the world converge to unravel the mysteries of this frozen realm. From the study of glaciology and climatology to astronomy and astrophysics, Antarctica has emerged as a global laboratory for scientific discovery. The unique environmental conditions, coupled with the continent's isolation from human interference, provide an unparalleled opportunity to conduct research that is crucial for understanding Earth's past, present, and future. Moreover, the spirit of collaboration that permeates Antarctic research transcends political boundaries, uniting nations in the pursuit of knowledge and understanding. The Antarctic Treaty System, established in 1959, has fostered a spirit of cooperation and peaceful coexistence among signatory nations, ensuring that the continent remains a bastion of science and diplomacy. An ever-changing world of mysteries beneath the ice. The icy expanse of Antarctica has long been a source of fascination and intrigue, its frozen surface concealing secrets that have sparked the imagination of explorers, scientists, and conspiracy theorists alike. Beneath its sprawling ice sheets, the continent holds the promise of new discoveries that continue to captivate the human spirit and drive the quest for knowledge. Ice sheets, which in some places reach depths of over a mile, lie mysteries that defy conventional explanation and challenge our understanding of history and the cosmos. Among the most tantalizing of these mysteries are the reports of ancient civilizations hidden beneath the ice. Tales of lost cities and advanced societies whispered by explorers and adventurers have fueled speculation about what lies buried beneath Antarctica's frozen surface. While mainstream archaeologists remain skeptical, proponents of these theories point to anomalous satellite images and alleged discoveries of man-made structures as evidence of a hidden history waiting to be uncovered. Perhaps the most sensational claim regarding Antarctica's enigmatic secrets came from a former naval officer and a journalist, who made headlines when they revealed their encounters with what they described as an entrance to an alien base deep within the continent's icy realms. According to their accounts, they stumbled upon a massive man-made structure protruding from the ice, surrounded by a mysterious aura of electromagnetic energy. Their claims, supported by alleged eyewitness testimonies of UFO sightings and secret government expeditions, paint a picture of a hidden world inhabited by extraterrestrial beings, an idea that stretches the bounds of credibility and challenges our understanding of reality. While such claims may seem far-fetched to many, they have nevertheless captured the imagination of conspiracy theorists and ethologists, who see Antarctica as ground zero for a clandestine extraterrestrial presence on Earth. The notion of ancient aliens shaping human history from the shadows, with Antarctica serving as a central hub of activity, has become a cornerstone of alternative historical narratives and pseudo-scientific speculation. Adding fuel to the fire are the discoveries of pyramid-like structures and other anomalous features visible beneath the melting ice of Antarctica. These enigmatic formations, captured in satellite images and aerial surveys, have prompted speculation about their origin and purpose. Could they be remnants of a lost civilization that once thrived in Antarctica's icy wilderness, or are they evidence of a more otherworldly influence? While mainstream scientists remain cautious in their interpretations, preferring to attribute such features to natural geological processes, the allure of the unknown continues to beckon researchers and adventurers to explore further. In recent years, advancements in technology and scientific research have shed new light on Antarctica's mysteries, revealing glimpses of a world hidden beneath the ice. From the discovery of subglacial lakes and rivers to the mapping of ancient landscapes preserved beneath the frozen surface, scientists have begun to unravel the secrets of this icy continent, painting a picture of a dynamic and ever-changing environment teeming with life and geological wonders. These findings, while not yet fully understood, open the door to a world of possibilities about Earth's past and the broader universe. As a heartbeat of scientific discovery, Antarctica stands as a testament to the resilience of life and the boundless potential of scientific inquiry. While the continent may be shrouded in tales of mystery and extraterrestrial intrigue, its true marvel lies in its unparalleled value as a hotspot of scientific discovery. From unlocking the secrets of Earth's climatic past to probing the mysteries of the cosmos, Antarctica offers a wealth of opportunities for researchers seeking to unravel the mysteries of our planet and beyond. At the forefront of Antarctic science is the study of extremophiles, organisms that thrive in the most extreme environments imaginable. These resilient life forms, capable of surviving in conditions once thought uninhabitable, challenge our understanding of the limits of life. From the depths of subglacial lakes to the harsh windswept plains, extremophiles have been discovered thriving in Antarctica's most hostile environments, offering insights into the potential for life to exist in even the most inhospitable corners of the universe. The discovery of microbial life beneath the ice shelf, in particular, has sparked excitement among scientists, raising tantalizing questions about the possibility of life beyond Earth. But Antarctica's scientific significance extends far beyond the realm of biology. The continent's ice cores, meticulously extracted from deep within its frozen surface, provide a unique window into Earth's climatic past. By analyzing the layers of ice, researchers can reconstruct past climate conditions with unprecedented accuracy, shedding light on the mechanisms driving global climate change and its potential impacts on the planet. From tracking atmospheric carbon levels to tracing the history of glaciation, Antarctica's ice cores offer invaluable insights into the complex interplay between Earth's climate systems, informing our efforts to mitigate the effects of climate change and protect the planet for future generations. In addition to its role in climate research, Antarctica also serves as a vital platform for astronomical observations. The continent's remote location, coupled with its clear skies and minimal light pollution, makes it an ideal site for studying the cosmos. Astronomers stationed in Antarctica have access to unparalleled views of the night sky, free from the interference of city lights and atmospheric pollution. From observing distant galaxies to studying the cosmic microwave background radiation, Antarctica offers a unique vantage point for exploring the deepest mysteries of the universe, pushing the boundaries of human knowledge and understanding. But perhaps the greatest value of Antarctica lies not in its individual contributions to science, but in its ability to foster international collaboration and cooperation in the pursuit of knowledge. Despite the political tensions that divide nations on other continents, Antarctica remains a beacon of unity, with researchers from around the world coming together to explore and study its icy expanse. Through joint research initiatives and shared resources, scientists are able to tackle some of the most pressing challenges facing humanity, transcending borders and ideologies in the quest for a better understanding of our planet and its place in the cosmos. The continent's unique conditions also make it an ideal site for astronomical observations, with its clear skies and minimal light pollution providing a window into the universe's depths. The quest for extraterrestrial intelligence, SETI, has long captured the imagination of scientists and enthusiasts alike, but recent revelations from Antarctica have reignited interest in this profound endeavor. As humanity peers deeper into the cosmos, from the detection of radio signals to the analysis of distant exoplanets, the age-old question persists: are we alone in the universe? The barren expanse of Antarctica, with its harsh conditions and otherworldly landscapes, serves as a stark reminder of the vastness and mystery of the universe. It is a place where the extremes of nature mirror the extremes of our own imaginations, a fitting backdrop for contemplating the possibility of life beyond our own planet. In recent years, advances in technology have brought the search for extraterrestrial intelligence closer to reality than ever before. The discovery of potentially habitable exoplanets orbiting distant stars has fueled excitement among astronomers, raising the tantalizing prospect of finding worlds teeming with life. Meanwhile, the development of powerful telescopes and sophisticated detection methods has enabled scientists to scan the skies for signs of intelligent alien civilizations, from elusive radio signals to enigmatic light pulses. But perhaps the most intriguing aspect of the search for extraterrestrial intelligence lies in our attempts to communicate with potential alien civilizations. For decades, scientists have sent messages into the void, broadcasting our existence and inviting contact with beings from distant worlds. These messages, whether in the form of radio signals or encoded data, represent humanity's hope and curiosity, our desire to reach out and connect with the unknown. Of course, the search for extraterrestrial intelligence is not without its challenges and controversies. Critics argue that the vast distances separating us from other star systems make meaningful communication unlikely, while others caution against the risks of attracting the attention of potentially hostile alien species. Nevertheless, the quest for SETI continues unabated, driven by humanity's innate curiosity and the belief that the search for life beyond Earth holds the key to understanding our place in the universe. These endeavors, while speculative, represent a desire to connect with the cosmos and find our place among the stars. The ethical and philosophical implications of discovering extraterrestrial life, whether through microbial findings buried beneath Antarctica's ice or the detection of signals emanating from distant galaxies, present humanity with profound questions. Such a monumental discovery would challenge our fundamental understanding of life, intelligence, and our place in the cosmos. It would force us to reconsider our role as stewards not only of our planet, but potentially of the broader universe itself. Imagine the implications of encountering life forms vastly different from our own, perhaps even possessing levels of intelligence and consciousness beyond our comprehension. How would such a revelation reshape our understanding of the nature of life? Would it force us to revise our definitions of intelligence and consciousness, recognizing that these concepts may manifest in forms far stranger and more diverse than we ever imagined? Moreover, the discovery of extraterrestrial life would raise profound questions about our responsibilities as inhabitants of Earth. Would we have a duty to protect and preserve these newfound life forms, even if they existed light years away? Would we be compelled to consider the impact of our actions not only on our own planet, but on the broader interconnected web of life that may extend throughout the universe? As we continue to explore Antarctica and push the boundaries of our scientific knowledge, we are constantly reminded of the vast expanse of the unknown that surrounds us. The White Continent, with its stark landscapes and hidden secrets, serves as a poignant metaphor for the uncharted territories of knowledge and understanding that lie ahead. Just as Antarctica once represented a seemingly impenetrable barrier to exploration, so too do the mysteries of the universe challenge us to venture into the unknown, to seek out answers to questions that have eluded us for millennia. What do you think about this? We hope you found these facts intriguing. If you've heard them before or have any thoughts to share, please let us know in the comments below. Don't forget to give us a thumbs up and subscribe to A World to Discover to join us on our journey of discovery. While you're still here, feel free to click on other videos you will see on the screen right now. The successor to the Hubble telescope is just about ready now to produce images of the universe like we have never seen before. It's also one of the most complicated pieces of technology ever built. It contains over 3,000 sensors that continuously monitor the status of the hardware so the technicians on the ground can keep an eye on what's happening. The Hubble Space Telescope, humanity's eye into the vastness of space, has reportedly captured an image so mysterious it stirred up more questions than answers. This isn't just any celestial body or distant galaxy we're talking about. This is something otherworldly. Today we're unraveling the tale of the City of God, a celestial phenomenon that has sparked debates, curiosity, and perhaps even a bit of fear. From a leaked photograph that took the world by storm to government cover-ups and the eerie sighting of celestial beings, this story has all the makings of a cosmic thriller. But what is the truth behind these bewildering claims? Are we on the verge of uncovering a divine presence in the universe, or is this a case of cosmic misinterpretation? And finally, if the City of God is real, what implications does it have for humanity's place in the universe? Hubble has consistently taken us to places we've never been, visually, of course, and has empowered us to answer questions that, in a previous generation of telescopes, we couldn't even pose. What excites me is that it shows us the wonder of the universe, places we can't get to right now. NASA's achievements since the monumental day when man first set foot on the moon have not just rested on its laurels, but have pushed the boundaries of what we believed was possible. With a brilliant team comprising the brightest minds in science, astronomers, engineers, and researchers, NASA has been the driving force behind the creation of spacecraft that seem to leap straight out of science fiction. These marvels of engineering have traversed the galaxy, sending back information that has unveiled the cosmos layer by layer. Each mission, from the Mars rovers to the Voyager probes, has been a thread in the rich tapestry of space exploration, revealing the mysteries of our solar system and beyond. But it's not just about the destination. It's also about the incredible journeys. The development and deployment of the Hubble Space Telescope stand as a testament to NASA's ingenuity and quest for knowledge. Hubble, orbiting Earth, has acted as humanity's window to the universe, capturing images that have not only advanced our understanding of the cosmos, but have also inspired millions around the globe with stunning visuals of distant galaxies, nebulae, and stars. Through decades of dedication, NASA's efforts have peeled back the layers of the cosmos, revealing the beauty and complexity of the universe in unprecedented detail. These achievements are not just milestones in the annals of space exploration, but are beacons of human curiosity and our unyielding desire to explore the unknown. One of the most electrifying updates from the cosmos is a discovery made by the Hubble Space Telescope that sent shockwaves through the scientific community and beyond. This isn't your ordinary snapshot of distant stars or swirling galaxies. This image has been described as terrifying, not because of its eerie aesthetics, but because of the profound questions it raises about our very existence in the universe. Imagine the Hubble, orbiting silently in the cold vacuum of space, capturing countless wonders on a routine basis, from the birth of stars to the death of galaxies. Each image is a testament to the natural beauty of the universe. But among these routine captures emerges an image so unexpected, so out of place, it takes everyone by surprise. The image reveals what appears to be a structure, composition so precise and unfamiliar that it defies all conventional understanding of cosmic formations. The immediate reaction is one of disbelief and shock. Scientists, used to deciphering the mysteries of the universe, find themselves at a loss, questioning not only the nature of this discovery, but also its implications for humanity's understanding of the cosmos. This is no mere celestial anomaly. Its presence suggests that there could be aspects of the universe that are entirely unknown to us, hidden realms or civilizations that exist beyond our current scientific comprehension. The potential impact of this discovery on our understanding of existence is monumental. It challenges the very foundations upon which our cosmic knowledge is built, inviting us to reconsider what we thought we knew about the universe. The core of our story revolves around an alleged photograph leak from none other than NASA itself. This isn't just any photo. We're talking about a snapshot that reportedly reveals a sprawling, large white city floating in the void of space, captured on December 26, 1994. This image quickly transcended from a confidential discovery to a global phenomenon, sparking shock and awe not just among the public, but within the scientific community as well. What makes the story even more intriguing is the context and timing of the discovery. It came from the Hubble Space Telescope, humanity's most advanced eye in the sky, which has been peering into the deepest recesses of the universe since its launch in 1990. The photograph in question surfaced at a time when the internet was just beginning to weave its web around the globe, a period ripe for rapid information exchange and, of course, speculation. Imagine the scene in NASA's offices when scientists first laid eyes on this baffling image. It was unlike anything they had seen before, a celestial anomaly that defied immediate explanation. The initial shock among the team was palpable. Here was a highly sophisticated space telescope designed to explore the cosmos and answer humanity's most profound questions, presenting them with an image that seemed to raise more questions than answers. The photographs leaked to the public turned scientific curiosity into a wildfire of speculation. The idea of a city floating in space challenges our understanding of the universe, provoking discussions about the nature of celestial bodies, the possibility of other civilizations, or even the concept of a heavenly abode. As this image made its rounds across the internet, it became a subject of fascination, debate, and wonder. People from all walks of life weighed in with their interpretations, theories, and, understandably, their skepticism. The scientific community was left to grapple with the implications of such a discovery, while the public imagination ran wild with the possibilities of what this city could represent. In today's digital age, the line between the extraordinary and the unbelievable blurs faster than a shooting star streaking across the night sky. But what happens when a discovery so monumental comes to light that it threatens to unravel the fabric of our reality? This is the story of an image captured by the Hubble Space Telescope that did just that, a photograph depicting what many have come to call the City of God, a celestial marvel that has set the internet ablaze with speculation, wonder, and a fair share of skepticism. Within moments of its alleged leak, the image coursed through the veins of the internet, igniting discussions in every corner of the globe. Chat rooms, forums, and social media platforms became the stages for heated debates and theorizing. The picture showing a vast white city amidst the stars was nothing short of a revelation, a glimpse into the divine, or perhaps a cosmic anomaly yet to be understood. But with great revelation comes great responsibility, and perhaps great panic. The U.S. government, sensing the potential for public unrest in the wake of such a bewildering discovery, moved swiftly. But not swiftly enough. Before the images could be tucked away into the classified archives, they spread far and wide. A testament to the age-old adage, once on the internet, always on the internet. The attempt to classify the images was seen by many as a knee-jerk reaction to control the narrative, to keep the public in the dark about a discovery that could redefine human existence itself. This action, rather than quelling curiosity, only fueled it further, leading many to question what else might be hidden within the vaults of governmental secrecy. These marvels of engineering have traversed the galaxy, sending back information that has unveiled the cosmos layer by layer. Each mission, from the Mars rovers to the Voyager probes, has been a thread in the rich tapestry of space exploration, revealing the mysteries of our solar system and beyond. But it's not just about the destination. It's also about the incredible journeys. The development and deployment of the Hubble Space Telescope stand as a testament to NASA's ingenuity and quest for knowledge. Hubble, orbiting Earth, has acted as humanity's window to the universe, capturing images that have not only advanced our understanding of the cosmos, but have also inspired millions around the globe with stunning visuals of distant galaxies, nebulae, and stars. Through decades of dedication, NASA's efforts have peeled back the layers of the cosmos, revealing the beauty and complexity of the universe in unprecedented detail. These achievements are not just milestones in the annals of space exploration, but are beacons of human curiosity and our unyielding desire to explore the unknown. One of the most electrifying updates from the cosmos is a discovery made by the Hubble Space Telescope that sent shockwaves through the scientific community and beyond. This isn't your ordinary snapshot of distant stars or swirling galaxies. This image has been described as terrifying, not because of its eerie aesthetics, but because of the profound questions it raises about our very existence in the universe. Imagine the Hubble, orbiting silently in the cold vacuum of space, capturing countless wonders on a routine basis, from the birth of stars to the death of galaxies. Each image is a testament to the natural beauty of the universe. But among these routine captures emerges an image so unexpected, so out of place, it takes everyone by surprise. The image reveals what appears to be a structure, composition so precise and unfamiliar that it defies all conventional understanding of cosmic formations. The immediate reaction is one of disbelief and shock. Scientists, used to deciphering the mysteries of the universe, find themselves at a loss, questioning not only the nature of this discovery, but also its implications for humanity's understanding of the cosmos. This is no mere celestial anomaly. Its presence suggests that there could be aspects of the universe that are entirely unknown to us, hidden realms or civilizations that exist beyond our current scientific comprehension. The potential impact of this discovery on our understanding of existence is monumental. It challenges the very foundations upon which our cosmic knowledge is built, inviting us to reconsider what we thought we knew about the universe. The core of our story revolves around an alleged photograph leak from none other than NASA itself. This isn't just any photo. We're talking about a snapshot that reportedly reveals a sprawling, large white city floating in the void of space, captured on December 26, 1994. This image quickly transcended from a confidential discovery to a global phenomenon, sparking shock and awe not just among the public, but within the scientific community as well. What makes the story even more intriguing is the context and timing of the discovery. It came from the Hubble Space Telescope, humanity's most advanced eye in the sky, which has been peering into the deepest recesses of the universe since its launch in 1990. The photograph in question surfaced at a time when the internet was just beginning to weave its web around the globe, a period ripe for rapid information exchange and, of course, speculation. Imagine the scene in NASA's offices when scientists first laid eyes on this baffling image. It was unlike anything they had seen before. A celestial anomaly that defied immediate explanation. The initial shock among the team was palpable. Here was a highly sophisticated space telescope designed to explore the cosmos and answer humanity's most profound questions, presenting them with an image that seemed to raise more questions than answers. The photographs leaked to the public turned scientific curiosity into a wildfire of speculation. The idea of a city floating in space challenges our understanding of the universe, provoking discussions about the nature of celestial bodies, the possibility of other civilizations, or even the concept of a heavenly abode. As this image made its rounds across the internet, it became a subject of fascination, debate, and wonder. People from all walks of life weighed in with their interpretations, theories, and, understandably, their skepticism. The scientific community was left to grapple with the implications of such a discovery while the public imagination ran wild with the possibilities of what this city could represent. In today's digital age, the line between the extraordinary and the unbelievable blurs faster than a shooting star streaking across the night sky. But what happens when a discovery so monumental comes to light that it threatens to unravel the fabric of our reality? This is the story of an image captured by the Hubble Space Telescope that did just that, a photograph depicting what many have come to call the City of God, a celestial marvel that has set the internet ablaze with speculation, wonder, and a fair share of skepticism. Within moments of its alleged leak, the image coursed through the veins of the internet, igniting discussions in every corner of the globe. Chat rooms, forums, and social media platforms became the stages for heated debates and theorizing. The picture showing a vast white city amidst the stars was nothing short of a revelation, a glimpse into the divine, or perhaps a cosmic anomaly yet to be understood. But with great revelation comes great responsibility, and perhaps great panic. The U.S. government, sensing the potential for public unrest in the wake of such a bewildering discovery, moved swiftly, but not swiftly enough. Before the images could be tucked away into the classified archives, they spread far and wide, a testament to the age-old adage, once on the internet, always on the internet. The attempt to classify the images was seen by many as a knee-jerk reaction to control the narrative, to keep the public in the dark about a discovery that could redefine human existence itself. This action, rather than quelling curiosity, only fueled it further, leading many to question what else might be hidden within the vaults of governmental secrecy. Secrecy, as the images continue to circulate, blurred the line between fact and fiction. Skeptics called it a hoax, a clever manipulation of light and shadow. Believers saw it as proof of the afterlife, a celestial city awaiting us all. The truth, as it often does, lay somewhere in between, shrouded in the mystery of the cosmos and the limitations of human understanding. Further analysis and observations were needed. Now, let's dive into further analysis and observations of the anomaly initially captured by the Hubble Space Telescope. After the initial shockwave caused by the leaked images of a supposed celestial city, NASA's finest minds convened in an urgent effort to verify the mysterious findings. With the world buzzing with theories and speculation, the decision was made to task the Hubble telescope with a mission of utmost importance. This wasn't merely a second glance. It was a full-scale, high-resolution investigation aimed at piercing the veils of the cosmos to uncover the truth behind the anomaly known as the City of God. Equipped with cutting-edge technology, the Hubble was meticulously programmed to capture the anomaly in the highest possible resolution. Scientists were not just looking for answers. They were seeking undeniable proof of what the structure truly was. The stakes were as high as the anticipation that filled the laboratory air. As the Hubble telescope focused its lenses on that specific section of the starry sky, hearts raced. The gathered scientists and astronomers knew they were on the cusp of potentially rewriting history. The subsequent capture of the photograph was a moment of truth. With bated breath, the image was projected onto a very big screen, instantly seizing the undivided attention of everyone present. What was revealed was nothing short of astonishing. The previously foggy and ambiguous spot was now clear, unveiling a structure that was at once luminous and architecturally complex. It was as if a light was shining from within the structure itself, casting an otherworldly glow across the cosmos. This presumed city, with its resemblance to speculative fiction and futuristic depictions, stretched into the vast expanse of space, igniting a myriad of questions and theories. Skeptical views and scientific inquiry soon followed. In a twist that was as intriguing as the discovery itself, the narrative shifted, ushering in the realm of skepticism and scientific inquiry. This turn of events cast a shadow of doubt over the celestial spectacle, painting it with strokes of uncertainty and speculative fiction. As we delved deeper, it became clear that not everyone was ready to take the leap from observable science to the acceptance of a city of God floating in the cosmos. The skepticism wasn't without reason. The scientific community, known for its rigorous standards of proof and evidence, found itself at a crossroads. The image, while mesmerizing, raised as many questions as it purportedly answered. Could this be a case of cosmic pareidolia, where human perception sees familiar patterns in random or vague images? Or perhaps a misinterpretation of astronomical data, transformed into a narrative more suited to science fiction than empirical science? The narrative underscored the potential for overinterpretation, a common pitfall in the quest to make sense of the unknown. With excitement reaching feverish heights, the distinction between hard evidence and the allure of speculative fiction became blurred. This skepticism served as a reminder of the importance of grounding extraordinary claims in solid scientific methodology and evidence. As the story unfolded, the skepticism not only challenged the veracity of the City of God, but also ignited a broader discussion about the nature of discovery and the human inclination to find meaning in the mysteries of the universe. It posed an essential question to us all. Where do we draw the line between the pursuit of knowledge and the seductive pull of storytelling that ventures into the realm of speculative fiction? Regarding the city's movement and cosmic role, as scientists scrutinized the images captured by the Hubble Space Telescope, they uncovered a movement that aligned with the grand cosmic ballet. The city didn't merely float in space. It followed a path that adhered to the fundamental laws of the universe. However, here's where it got even more fascinating. The city was described as acting almost like a cosmic lighthouse, a point from which galaxies seemed to drift away. This movement wasn't random. It was orderly, following the principles laid out in the Big Bang Theory, suggesting that this city was not just a part of the universe but a central figure in its expansive dance. This revelation sent ripples through current cosmological models, changing the way we perceive the structure and dynamics of the cosmos. Imagine a model of the universe where Earth isn't at the center, nor is the Sun, but perhaps this mysterious city of light. Scientists even employed computer models to illustrate how galaxies drifted away from this enigmatic point, inviting us to reconsider our place in the universe's vast tapestry. Allegations of NASA hiding the discovery soon emerged. Following the initial leak of this extraordinary image, the reaction was swift and shrouded in secrecy. The U.S. government allegedly stepped in with a heavy hand, classifying the images to stifle the swell of public unrest. This wasn't merely a routine operation. It was an act driven by the fear of the unknown, a testament to the potentially destabilizing impact of the discovery on societal norms and beliefs. But the plot thickened. Despite efforts to keep the images under wraps, a photographer at Ellington Airfield, armed with nothing more than a camera and a keen eye, managed to capture snapshots of the supposed celestial marvel. These images, adorned with structures that seemed to defy human comprehension, found their way onto the internet, igniting a firestorm of speculation and debate. As the decoding of the image continued, formations appeared impossibly structured, bearing an uncanny resemblance to the architectural feats of an advanced civilization. Towers stretched towards the stars, domes shimmered with an ethereal glow, and most intriguingly, figures appeared distinctly lifelike. These elements threw the scientific community into a whirlwind of speculation and debate. In addition, reports of figures resembling angels near the celestial city added another layer of mystique. Described as having brilliant orange hues, massive wings, and an appearance of joy, these sightings were reminiscent of past accounts from Soviet cosmonauts during the Soyuz mission. This led to a tantalizing question. Have we, over the years and through the lens of different cultures, been witnessing the same celestial phenomena? The public and cultural reaction to the discovery was equally intense. The City of God became a mirror reflecting humanity's deepest yearnings and beliefs. Across the globe, people grappled with the implications of this celestial phenomenon. Was this the architectural manifestation of the divine? A celestial abode among the stars? The reaction was diverse, sparking curiosity and a re-evaluation of our understanding of the universe. Comparative analysis with past claims, like the 2016 Gates of Heaven incident, reminded us to tread carefully. As we've seen with past claims, the excitement of such discoveries often outpaces the reality of the evidence. Secrecy, as the images continue to circulate, blurred the line between fact and fiction. Skeptics called it a hoax, a clever manipulation of light and shadow. Believers saw it as proof of the afterlife, a celestial city awaiting us all. The truth, as it often does, lay somewhere in between, shrouded in the mystery of the cosmos and the limitations of human understanding. Further analysis and observations were needed. Now, let's dive into further analysis and observations of the anomaly initially captured by the Hubble Space Telescope. After the initial shockwave caused by the leaked images of a supposed celestial city, NASA's finest minds convened in an urgent effort to verify the mysterious findings. With the world buzzing with theories and speculation, the decision was made to task the Hubble telescope with a mission of utmost importance. This wasn't merely a second glance. It was a full-scale, high-resolution investigation aimed at piercing the veils of the cosmos to uncover the truth behind the anomaly known as the City of God. Equipped with cutting-edge technology, the Hubble was meticulously programmed to capture the anomaly in the highest possible resolution. Scientists were not just looking for answers. They were seeking undeniable proof of what the structure truly was. The stakes were as high as the anticipation that filled the laboratory air. As the Hubble telescope focused its lenses on that specific section of the starry sky, hearts raced. The gathered scientists and astronomers knew they were on the cusp of potentially rewriting history. The subsequent capture of the photograph was a moment of truth. With bated breath, the image was projected onto a very big screen, instantly seizing the undivided attention of everyone present. What was revealed was nothing short of astonishing. The previously foggy and ambiguous spot was now clear, unveiling a structure that was at once luminous and architecturally complex. It was as if a light was shining from within the structure itself, casting an otherworldly glow across the cosmos. This presumed city, with its resemblance to speculative fiction and futuristic depictions, stretched into the vast expanse of space, igniting a myriad of questions and theories. Skeptical views and scientific inquiry soon followed. In a twist that was as intriguing as the discovery itself, the narrative shifted, ushering in the realm of skepticism and scientific inquiry. This turn of events cast a shadow of doubt over the celestial spectacle, painting it with strokes of uncertainty and speculative fiction. As we delved deeper, it became clear that not everyone was ready to take the leap from observable science to the acceptance of a city of God floating in the cosmos. The skepticism wasn't without reason. The scientific community, known for its rigorous standards of proof and evidence, found itself at a crossroads. The image, while mesmerizing, raised as many questions as it purportedly answered. Could this be a case of cosmic pareidolia, where human perception sees familiar patterns in random or vague images? Or perhaps a misinterpretation of astronomical data, transformed into a narrative more suited to science fiction than empirical science? The narrative underscored the potential for overinterpretation, a common pitfall in the quest to make sense of the unknown. With excitement reaching feverish heights, the distinction between hard evidence and the allure of speculative fiction became blurred. This skepticism served as a reminder of the importance of grounding extraordinary claims in solid scientific methodology and evidence. As the story unfolded, the skepticism not only challenged the veracity of the City of God, but also ignited a broader discussion about the nature of discovery and the human inclination to find meaning in the mysteries of the universe. It posed an essential question to us all. Where do we draw the line between the pursuit of knowledge and the seductive pull of storytelling that ventures into the realm of speculative fiction? Regarding the city's movement and cosmic role, as scientists scrutinized the images captured by the Hubble Space Telescope, they uncovered a movement that aligned with the grand cosmic ballet. The city didn't merely float in space. It followed a path that adhered to the fundamental laws of the universe. However, here's where it got even more fascinating. The city was described as acting almost like a cosmic lighthouse, a point from which galaxies seemed to drift away. This movement wasn't random. It was orderly, following the principles laid out in the Big Bang Theory, suggesting that this city was not just a part of the universe but a central figure in its expansive dance. This revelation sent ripples through current cosmological models, changing the way we perceive the structure and dynamics of the cosmos. Imagine a model of the universe where Earth isn't at the center, nor is the Sun, but perhaps this mysterious city of light. Scientists even employed computer models to illustrate how galaxies drifted away from this enigmatic point, inviting us to reconsider our place in the universe's vast tapestry. Allegations of NASA hiding the discovery soon emerged. Following the initial leak of this extraordinary image, the reaction was swift and shrouded in secrecy. The U.S. government allegedly stepped in with a heavy hand, classifying the images to stifle the swell of public unrest. This wasn't merely a routine operation. It was an act driven by the fear of the unknown, a testament to the potentially destabilizing impact of the discovery on societal norms and beliefs. But the plot thickened. Despite efforts to keep the images under wraps, a photographer at Ellington Airfield, armed with nothing more than a camera and a keen eye, managed to capture snapshots of the supposed celestial marvel. These images, adorned with structures that seemed to defy human comprehension, found their way onto the internet, igniting a firestorm of speculation and debate. As the decoding of the image continued, formations appeared impossibly structured, bearing an uncanny resemblance to the architectural feats of an advanced civilization. Towers stretched towards the stars, domes shimmered with an ethereal glow, and most intriguingly, figures appeared distinctly lifelike. These elements threw the scientific community into a whirlwind of speculation and debate. In addition, reports of figures resembling angels near the celestial city added another layer of mystique. Described as having brilliant orange hues, massive wings, and an appearance of joy, these sightings were reminiscent of past accounts from Soviet cosmonauts during the Soyuz mission. This led to a tantalizing question. Have we, over the years and through the lens of different cultures, been witnessing the same celestial phenomena? The public and cultural reaction to the discovery was equally intense. The City of God became a mirror reflecting humanity's deepest yearnings and beliefs. Across the globe, people grappled with the implications of this celestial phenomenon. Was this the architectural manifestation of the divine? A celestial abode among the stars? The reaction was diverse, sparking curiosity and a re-evaluation of our understanding of the universe. Comparative analysis with past claims, like the 2016 Gates of Heaven incident, reminded us to tread carefully. As we've seen with past claims, the excitement of such discoveries often outpaces the reality of the evidence. Discovery. While you're still here, feel free to click on other videos you will see on your screen right now.